light?
Yeah.
Okay.
Which one is it? Is it the
I'm
far
getting
one?
like
The only one that's on should be.
At least you
It's
can.
the only
There you go.
one that's on. Okay, that was funny.
Okay,
Oh, yeah.
so let's take a look at this first one. Bill and Emily, parents of the year, ordering fast food for their families. I will not judge. Okay, I do this plenty. Bill orders 2 burgers and 3 orders of fries, and the total cost of his meal is $8.50. Emily orders. This is for his whole family.
What?
Yeah.
No way.
I know.
Dude,
I
I'm
said my-
Emily orders 4 burgers and 2 orders of fries, and the total cost of her meal is $11. So what is the cost of a burger and an order of fries? The very first thing you've got to do with one of these problems is define your variables. Okay, you'll remember me talking about this from way back when we did equation solving. When I say define your variables, I want to know what are the things that you're trying to find here. Okay, what's something that I'm trying to find here?
The cost.
The cost of...
the meal.
Okay, so I want the cost of a burger to be my x. And notice I'm not just writing burger, I'm writing cost of burger. Because if you just write burger, I don't know if you're talking about the number of burgers you're buying. I don't know if you're talking about the weight of a burger. Okay, I guess I should say cost of a burger. Okay, so what's my y going to be? What's my other thing I'm trying to find? Cost of fries, yep. So x is cost of a burger, y is cost of fries. Okay? X is cost of a burger, y is cost of the fries. And we're comparing Bill's meal and Emily's meal, right? So I'm going to write 2 different equations, one for Bill, one for Emily. So let's see who's first here. Bill. Bill is ordering 2 burgers and 3 orders of fries. How am I going to write an equation that shows that? 2 burgers, 3 orders of fries.
2x plus 3y
Okay,
equals 8.
there you go. 2x plus 3y equals 850. And then Emily's orders 4 burgers and 2 orders of fries. So hers is going to be
4x
Uh-huh.
plus
Preach it, Courtney.
2y
Isaiah
Sorry.
$11.
equals $11 for her. Okay, did you follow that okay?
Yee.
The people who were not speaking, did you follow it okay?
Yeah.
Okay. All right. Now that looks just like the problems you've been solving all along, right? Let's try to solve it. What do you want to use? Substitution or elimination? I would use elimination, I think. Okay? Because there's no variable that would be easy to solve for. Okay? What do you want to multiply by? Okay, if we multiply by -2 on the top, that's going to take care of that. It's going to turn that 2 into a -4. So that's going to become -4x minus 6y equals -17. -2 times 850 is going to be -17. Okay. Add together, so those cancel. This is going to give me -4. And 11 plus -17 is going to give me -6. Divide by -4. And I get y equals 1.5. Decimals are not out of the question here because remember this is a cost. This is money. Okay, so unless things are exact dollar amounts, $2, $4, whatever, decimals are going to happen here. All right, let's plug that back in. Which one do you feel like plugging into?
Top.
Really?
No.
I would probably go with the second one.
Yeah, me too.
Just because, not like it would be, I mean, you could do it with the top one too, but,
I was just testing you.
oh. I just like the fact that this one is not going to make me do decimals, so.
Yeah, me too.
Thanks, Isaiah. All right, 4x plus 2 times 1.5 equals 11. 2 times 1.5 is 3. So 4x plus 3 equals 11. Subtract 3, subtract 3. 4x equals 8. Divide by 4. And x equals 2. Okay, I would probably not write this as a coordinate. Why? Say it again?
It's not a point.
Right, it's not a point on a coordinate plane. We're not graphing this, okay? What do these numbers mean?
The cost of fries and burgers.
Okay, so a burger costs $2. French fries cost $1.50. Okay? So I would say something along the lines of, well, and I guess you could even come back up here to where you defined your variable and say the cost of burger is $2 and the cost of fries is $1.50. Okay? Just to show that you understand what these numbers represent. You don't have to write them as a final coordinate, but do something, either label your answers or put them back up here with your variables to show what they represent. All right, number 2, kind of a ridiculous question, but I saw it and I liked it, so we're going to do it. There are 13 animals in a barn. Some are chickens, some are pigs. There are 40 legs altogether. How many of each animal are there? All right, what are our variables going to be here?
Chickens.
Okay,
pigs.
number of chickens and number of pigs, right? So X is going to be my number of chickens. And Y is going to be my number of pigs. Okay. Let's start with this. There are 13 animals in a barn. I've got pigs and chickens. How am I going to write an equation to show that altogether there are 13 animals? That's it. X plus Y equals 13. Okay? So that first equation is just talking about how many there are. Now, this one is a little bit different. Most of the problems have all of the information kind of spelled out for you. There's some stuff that's sort of implied here. Because then all it tells me is that there are 40 legs altogether. Okay? But I can't just do X plus Y equals 40 because it's not, the 40 does not represent the total number of chickens and pigs. What do I have to know here? Okay? How many legs does a chicken have?
3.5.
2. How many legs does a pig have? 4, barring any sort of traumatic injury, right? So how can I write an equation to show that for every chicken I get 2 legs and for every pig I get 4 legs? I heard 4x. I don't want to do 4x. I want to do 2x, right? Because chickens have 2 legs. 2 legs for every chicken plus 4 legs for every pig. So this equation represents how many legs I have. So this is how many animals, this is how many legs. My number of legs should be 40. What do you want to do to solve this one? You want to do substitution? Okay. Substitution, you want to solve for X or Y? What do you think?
Y.
Sure, Y. So if I solve this one for Y, I'm going to get Y equals negative X plus 13. If I move that X to the other side, it's going to be negative. I'm going to plug that negative X plus 13 in for Y down here. Okay. So then I'm going to have 2X plus 4 times negative X plus 13 equals 40. Okay. Let's distribute the 4. So 2x. 4 times negative x is going to give you negative 4x. And 4 times 13 is going to give you 52. Okay. 2x minus 4x is negative 2x. I'm running a little short on space, but if I subtract 52 from each side, I'm going to end up with negative 2x equals negative 12. Divide by that negative 2, and I get x equal to 6. What's that mean? 6 chickens. Yeah, x is my chickens. Okay, so I have 6 chickens. Okay. Would decimals make sense in this problem? No, you are not going to have 0.4 of a chicken. Okay? So make sure you're thinking about the context of the problem. Sometimes decimals are going to make sense and sometimes they won't. All right? Let's go back and figure out how many pigs we would have to have then. And really, a lot of you are going to say to yourself, well, I know I have 13 altogether, so if 6 of them are chickens, 7 of them must be pigs. Okay, that's perfect. That's exactly right. If I were to do this, if I was to plug this in, I would get y equals -6 plus 13, which does mean y equals 7 pigs. Okay, so there's my answer. And if I were to go back and check, that would mean I would have 12 legs from the chickens, okay, because 6 times 2 is 12. And I would have 28 legs from the pigs, because 4 times 7 is 28. 12 and 28 does make 40, so that's correct. Okay, let's do, I want to jump down to number 5. Let's take a look at number 5. Because the one on your quiz is most similar to number 5. The difference of two numbers is 7.
What is the quiz?
Wednesday. Okay? I'll say that a few more times before the end of class. The difference of two numbers is 7. The first number is 5 less than twice the second number. Find the two numbers. What are my variables here? What things am I trying to find? Now hold on a second, because I see that a lot. So wait just a minute. Back up here when we were defining variables, did we put numbers anywhere? Did we say that X was going to represent the 3 orders of fries? No. But I see in these problems all the time, the one similar to number 5, people doing that, is saying that the first variable must be 7. 7 is not a variable. A variable is a value we don't know. Okay, we do know the number 7. What two things am I trying to find? Find the two numbers, yeah. So X is going to be a number. I don't know what number, but it's going to be some number. And Y is going to be another number. Okay? So X is a number, Y is another number. And what you've got to be careful of here is, yes, they both represent numbers, but I want you to do something in here to show me that they're two different numbers. So don't just say X is a number and Y is a number. All right? See how I used the word another? Or you could say first number and second number. Something to show me that they're two different numbers. Okay. The difference of two numbers is 7. What does difference mean? Subtract. So I know when I do X minus Y, I'm going to get 7. Okay? And this is where we go back to, this is like the very first thing we did at the beginning of the year, where we went word by word. You remember this? So the first number, which is my X, is, what do I put in for is? Is equals. Remember way back, this was very, very beginning of the year. We said things like the sum of 2 and 3 is 5, and we talked about how the word is equals. So the first number is 5. What's less than mean? Subtract, thank you. Except remember with less than, you've got to switch the order. Like if I say 3 less than 5, it doesn't mean to do 3 minus 5, it means to do 5 minus 3. Okay, so after I write this out, I'm going to have to switch the order of these things. Less than is kind of a weird one. Okay, less than, you're going to do subtraction, but you're switching the order. How do I do twice the second number?
Is that 5 times 2?
Nope, the second number is our Y, right? It's our number that we don't know. So twice means 2 times Y, and then less than means I'm going to have to flip this around. So my equation is going to look like this. X equals 2Y minus 5. Okay? Because if I want to do 5 less than 2Y, that means I'm starting with 2Y and taking 5 away. All right, look at how this is set up. What's going to be my easiest way to solve this one, you think? Yeah, I would go with substitution because this one already has X by itself. So let's take what X equals, put it in up here. So now I'm going to have 2Y minus 5 minus another Y equals 7. Well, 2y minus y is just y. So now I have y minus 5 equals 7. Okay. Add the 5 to the other side, and I end up with y equal to 12. Then you can plug that back in whichever place makes more sense to you. Usually we would plug right back in here for this one. This one might actually be easier to plug into, but so I would do x equals 2 times 12 minus 5. Let's see, that's 24 minus 5, which is 19. So x equals 19. Is it true that the difference of 19 and 12 is 7? The difference between 19 and 12 is 7?
Yeah.
Yep. Okay. And is 19 5 less than twice 12? So let's, sorry, I know that sounded confusing. If I plugged my numbers in here, would it work? That's basically what I'm doing. So if I put 19 in for x, I'm just kind of checking it here. You wouldn't have to necessarily write this out, but does this work out to be true? That 19 is equal to 2 times 12 minus 5?
Yep.
Yep. Okay, so 12 and 19 are our true numbers. Okay. Kind of a tough one to get set up, but that's how you would do that one. Take a look at 3 and 4. Do you feel like we need to do either one of those? Happy to do it if you want me to. Okay. I'm going to go ahead and give you your assignment so you can start working on it.